Hey guys, sorry I'm out today. My throat's really bothering me and I'm starting to feel pretty sick. So figured I'd stay at home and keep it away from you guys. Sorry. I did want to show you guys um, something from the next chapter. So my thought is I'll probably, hopefully I'll be back tomorrow, Thursday, and we can review for the statistic and parameter stuff that we talked about, and then have that short quiz on Friday, and hopefully I'll have all your guys' retakes graded by then too. I may need to stop into school today and grab them. But anyway, I wanted to show you guys how to calculate standard deviation of a sample. Okay. On Khan Academy, you're going to watch how to calculate the standard deviation of a population. And again, so population is literally everybody that you could ever be interested in, right? So if your question is how much does the average family spend on a cell phone plan in the United States, your population would be literally every family in the United States. If you took a sample of like 4,000 families, then you'd have a sample. It's essentially the same. There's just one small change that I'll explain here in a minute. So all right, so let's go through this, and I hope I can help this make sense for you guys. It looks awful. I mean, if you look at this looks terrible, but it actually is quite simple once you get the hang of it. So, okay, the administrators at Metro want to know the average number of hours of sleep that Metro students are getting, as well as the standard deviation for this data set. A random sample of the high school population was taken, and the following results were obtained. Okay. So again, pretty small sample here. Obviously, you'd want to sample more than, 7 people. But here's a sample. The first thing you need to do is calculate the average, okay? So the idea is what we're going to do is we're going to calculate the average, and the standard deviation is just kind of a measure of how far everybody is away from the average, okay? So if you add all these up, 1, 2, 3, 4, 5, 6, 7, and you divide by 7, you'll get 8, okay? So the average for this data set is 8, okay? When you see this little X bar thing like this, that means the average of a sample, okay? That's what the X, but we call that X bar. There's a little bar above it, okay? Now, these are the X sub i's. The X sub i's are just like, so if I wanted, I'm going to talk about X sub 1 here. Okay, so X sub 1 is the first data point. It is the first X. X sub 2, if I wanted it, would be the second data point. X sub 3 would be the third data point, so on and so forth. We put X sub I because we generalize, right? So the first data point that you're going to be interested in is 6. Okay, the second data point that you're interested in is 7, then 7, then let's see, 7.5, 7.5. So 7.5, 7.5, 10, whoop, 10, and then I think the last one was 11, right? Yeah. So, and then this is 11. All right. And bear with me here for a sec. I'm going to center all these things. Okay. Anyway, this isn't working out so well, but whatever. Okay. Then what we're going to do, so the standard deviation is giving us an idea of how spread out the data is, or how far the data points tend to be from the average. So in order to do that, what we're going to do is we're going to take every data point and we're going to figure out how far it is from the average, okay? So what we're going to do is we're going to do the X sub I that we happen to be on, and we're going to subtract the average, or the mean, the sample mean, okay? In our case, the sample mean was 8, so here we've got 6. So 6 minus 8 is -2. 6 minus 8 is -2. 7 minus 8 is -1. -1, -0.5. And again, I'm just taking everybody over here and subtracting 8. So -0.5. 10 minus 8 is 2. 11 minus 8 is 3. Okay? So once you figured out how far everybody is away from the mean, what you're going to do is you're going to square those results. This may sound kind of familiar to what I was doing with our dice predicting activity. It's because essentially I was doing this. So, all right. So what is negative 2 squared? Negative 2 squared is 4. Negative 1 squared is 1. Negative 1 squared is 1. Negative 0.5 squared is positive 0.25. And notice, by the way, these answers are all positive. Okay? Should not get negative results once you square things. All right, so 0.25. 2 squared is 4. 3 squared is 9. Okay. Now we get to our first really ugly looking thing. Okay? Let's talk about this for a second. I'm going to zoom in. Let me go a little further. Okay. So we have all of our data points, and we figured out if you subtract the sample mean from them and you square that result, we have all those. What we're going to do is we're going to add all those things up. So we're going to do 4 plus 1 plus 1 plus a quarter plus 4 plus 9, which, let's see, what is that? 6 and a half, 10 and a half, 19 and a half, I think. 13. Yeah, so 19 and a half. Okay, so let's talk about what this notation is. Okay, this is our little summation guy, right? We call this guy sigma. Okay, this little E looking thing. Okay, what this is this means that we just start at I equals 1 and we go till the last number. We put n here because we don't know what the last number is a lot of the times, but how many data points do we have? We had 7, right? So technically, in our case, this is from 1. We start at the first data point and we go till the 7th data point, okay? You don't need to change that, but I'm just trying to walk you through how people actually use this. This is called sigma notation right here, okay? What we've done is we did x sub 1 minus the mean squared, okay? What was x sub 1 minus the sample mean squared? It was this number right here, okay? Then we did x sub 2 minus the sample mean, and we squared it, okay? So this notation is just a very quick and easy way of saying, hey, take all of the data points, subtract the sample mean, get that number, square it, and then all I want you to do is add those things up. So this is just a big, efficient, lazy way of saying, hey, add up this column right here. So like we said, that's 19 and a half. Okay. All right. So now that we have that, we have figured out all the sums, or sorry, we have summed up all of the squares of every data point's distance from the mean. Okay. So we got 19.5. Now what we're going to do is we are going to calculate the variance. The variance is just kind of this, second to last step before we get to the standard deviation. Bear with me here. This looks awful, but it's not terrible. Okay. See the little summation of x sub I minus x bar squared. Okay. We just calculated that. We already have that number. Okay. So that number that's our 19.5, right? Okay. And then what we're going to do is we're going to divide that by n minus 1. Okay? What was n? Remember, in statistics, n pretty much always refers to the number of people in your sample, which in our case was 7. So we're just going to do 7 minus 1. So really, what are we doing here? We're doing this 19.5 over 6, right? So bear with me here. Sorry, I didn't work these out beforehand. So that's 3.25. Okay. So once we figure this out, this is 3.25. Okay. Okay. So 3.25 is what we call the variance. We will talk about the variance a little more later, but the idea here is that we denote the variance by this little guy is called sigma. So this is lowercase sigma. These are Greek letters, by the way. This is their version of the capital letter S. This is their version of the lowercase letter s. Okay. So this is sigma squared. All we're going to do to find the standard deviation is take the square root of this number. So we're just going to take the square root of 3.25. 1.8. Okay. 1.8. So the standard deviation here on this data set is 1.8. So question for you, if we break these numbers apart and we make them further away from the average, so like let's say we did 1, 2, 3, let's do 8, 9, 12. All right, I need to make the average still 8 for this. So 1, 2, 3, that's 6, 14, 23, 35. Let's do 21 here. Okay, so if we change this here, 1, 2, 3, 8, 9, 12, 21, and we divide by 7, we should still get 8. Let me just double check that real quick. 33, 42, 50, 56 over 7 is 8. Okay, yep. So now this data set still has the same mean as the other one, but notice how the numbers, I purposely made them further away from 8. Okay, well, except for 8. 8's pretty close to 8. Okay, now if we were going to do this, okay, so let's remember this number for a second, this 1.8 standard deviation. Okay, what I claim here is that the standard deviation for this sample here should be quite a bit larger, like considerably larger is my guess. Okay, it's probably going to be closer to like 5 or 10, but let's just do it real quick. So 1, 2, 3, 8, 9, 12, and 21. I'm going to zoom out a little bit here. 8, 9, 12, 21. All right. Okay, so the average is still 8. So how far is everybody from 8? 1 minus 8 is negative 7. 2 minus 8 is negative 6. 3 minus 8 is negative 5. 8 minus 8 is 0. 9 minus 8 is 1. 12 minus 8 is 4. 21 minus 8 is 13. Okay, cool. So if we square these, we get 49, 36, 25, 0, 1, 16, and 169. If we add these up, we get 85, 110, 111, 127 plus 169. 127 plus 169. 296, I believe. Let's see, this would be 185, 186, 211, 247, 296. Okay, cool, yep. So if you take all these guys and add them up, you'll get 296. If you take this column here, add it up, you'll get 296. How many data points do we have? We had 7, so we're going to do 296 over 1 less than 7. So we'll do 296 over 6. And we get, thanks Wolfram Alpha, 148 over 3. That helps. All right, 49.3. So 49.3. That's the variance, and then we just take the square root of that. So 7.02. 7.02. Okay, so this number here just numerically gives you a feel for how far or how spread out the data is. Okay, and that's how standard deviation works. Like I said, I guess this one would be between 5 and 10. This one's 7.02, right? So you can imagine if we did this even further, right? Like -5. I don't even know what data set would have, things that are -5. But if we start to change these and skew them further away from 8 while still maintaining an average of 8, I'm not going to figure out the math here on this, but you'd get an even bigger standard deviation. Okay, so that's the idea with standard deviation. Let me say one other thing. Khan Academy uses the exact same formula, except instead of n-1, they use n for their standard deviation. If you have a sample, we put in n-1 here to calculate the variance. If you have a population, you can actually just use the number n. There's a very convoluted, complex reason for why we do that, which I feel like is outside the scope of this class, but some of you are going to wonder, why does Mr. T's formula not match their formula? So that's why. Okay, I hope that helps and makes that clear, and I miss you guys, and hopefully I'll see you tomorrow.